Okay, so yesterday we were talking about this problem. I said I'd record a video for you guys. So let's take a look at what we have here and what there's some things that I did yesterday that were good and some things that I did that kind of put us in the wrong direction. So, all right. So if we start by thinking about it, if we think about our triangles, remember it tells us this is a right angle. So if I'm looking at this purple one, okay, I could definitely, I need the tangent in there, so I'll say the tangent of x equals opposite AE over adjacent AB. So I have that, and I'll keep purple for that triangle for later. And if I look at this triangle, see if the red works. Yep, it does. This triangle here, that will get the tangent of y in it. And I'll put that over here. Tangent of y, AD over AC, okay, for ourselves. Right, so we have those pieces of information. So remember, we had to bring the tangent of x and the tangent of y into. Okay, so we're going to kind of look at that, keep that in the back of our mind here, that we have this information as we go through and we do it. Okay, now, if I look at this little triangle in here, and let me highlight that little triangle I have right here. Okay, so if I look at this triangle that I have here, okay, this angle right here, sorry, I'm not doing a little one, I'm going to do that one right up there, which the green is not working on. All right, green. Okay, I'm going to call this angle right here, I'm going to call it alpha, all right, just to help me out as I do that. All right, and as I look at it then, if I look at this whole angle for myself, for this entire thing, this is the entire thing, we're going to have that the sine of DAE over DE equals the sine of D over AE for that triangle I had in green right there, okay? Now you're going to see why I brought the alpha in. Look at the alpha. 90 plus the alpha, right, gives us angle DAE, right? So I'm going to cross out DAE and put 90 plus alpha there. If we look at DAE, alpha plus 90, okay? Now as I look at that, I see sine of 90 plus alpha. Hey, wait a sec, right? We've done that earlier this year. We thought about how these relate to each other, okay? If I think about that, this takes it back a quadrant. If you take it back, if you change the quadrant, then that becomes a cosine. And this angle, which is obtuse, if you take away 90, it's the same reference angle, but as a first quadrant angle, right? So it's just going to be the cosine of alpha, right? So that's something that we talked about earlier this year, how to rewrite these as just the trig function. Okay, so now that we have that, right, we can then say from this that DE, right, once I work with this fraction, I'm going to move that over here. DE is AE cosines of alpha over the sine of D, okay, for myself. Okay. So unfortunately, I have this cosine of alpha in the problem that I have to deal with. Okay, right? But now, let's look at that middle triangle for ourselves. Okay, if I look at that middle triangle that I just put in pink there, right? If I'm looking at this angle, right, remember that from the beginning that this was a right angle right here, that this red triangle had a right angle. So this is 90. This is 90. I'm going to take away alpha, so this is 90 minus alpha. So if I'm setting up for that pink triangle in the middle, it's sine of 90 minus alpha over BC equals sine of y over AB, okay, that we'd have for myself, okay? I could also go the other way, right, but I've just chosen to do sine of y for this one, right? I could have done the sine of x, and but we'll worry about that later. I just picked one of them. Oh, cofunction, cosine of alpha All right, that's our cofunction there by definition. So that's also cosine of alpha. Hey, look, cosine of alpha is right here. So I'm going to solve that for cosine of alpha and then plug it in. Okay. Now that's going to get plugged in right here to that green equation. That's the green, that doesn't work. Okay. All right, so my green equation, I'm going to have dE equals, and then I have AE. I'm going to leave that kind of separate. Oh, AE over sine of D. And then the cosine of A is going to become this. BC sine Y over AB for myself. Okay, so now I have that. Okay, I'm just double checking that I wrote everything correctly. Yes, I did. Okay, so now that I look at that, right, for myself, remember, I'm trying to get the tan of x and the tan of y into it. As I look at it, I have an AB and an AE. I could shuffle these, and then I would have AE over AB, and then I'd have this extra BC, right, which is okay because I need the BC on its own, so I'll put that over here, and then I have the sine of y over AB as that middle. So I just kind of broke it up, right? The BC on its own, because that's part of what I'm trying to prove. The AE over AB, that's the tangent of x. So I'm making some great progress here. I have the BC I need. I have the tangent of x I need. Now I need to turn that into the tangent of y. Okay? But if you look at it, it doesn't look too obvious yet. So let me go back to that red triangle that had that tangent of y in it. And let me do some right triangle trig there to help me with the sine of y. So if I look at that red triangle, the sine of y for that red triangle would be AD over DC. AD over DC from that red triangle. All right, opposite over hypotenuse there. Okay, so I'm going to go ahead and plug that in right here for the sine of y. So now I'm going to have, make sure I get my colors right, I'm going to have times, hold on, I see I made a mistake here, hold on. Oh, I see I made a mistake. When I flip-flopped these, I wrote the sine of y twice. That's supposed to be sine of d. There we go. Okay. All right, sorry about that. Okay, I had AB twice, so should have had sine of d there. So I have the sine of y, that's going to be AD over DC. Okay, now I need the sine of d for myself. Again, if I go to that red triangle over here, here's the red triangle, sine of d. That would be AC over DC. Okay. So if I plug that in over here for the sine of d, AD over DC, sorry, AC over DC. Oh, I'm getting so many letters. Okay. And let me just double check. I put everything in right because there's so many different letters there. Okay. Well, the dividing by DC's cancel. So this fraction is now AD over AC. Hey, AD over AC, that's the tangent of y. Okay. And now I've finished my proof as we've done it, right? Okay. I've shown that DE, remember I had the DE up here, that came down. That DE equals BC times tangent of x, tangent of y. Okay? Right? Tricky problem, definitely, right? But doable. There's a lot of triangles going on there, so I hope the color coding helped.